Appreciate the folks that we have here today. We're going to talk a little bit about wearable technology and how we can use it to improve human performance. I'm representing GoXtudio today as the Chief Operating Officer, but I'm just going to tell you a little bit about two other companies that we have as well, because they all kind of are part of our universe of companies that provide service. Wearable Robotics Association, my business partner and I started realizing that in order to stay connected with the technical groups, even outside of product design and development, we wanted to start leading some of the discussion that was going on. So we started up the Wearable Robotics Association. It's a trade association. In fact, my buddy Joe Hidd is leaving for China tomorrow. We're funded by NIST to help represent the United States internationally in establishing wearable robotics testing standards as ISO starts to develop those. And so he's in China tomorrow. We just got back from Germany with one of our team to do that. We have a conference in February in Arizona. So if anybody is thinking that they're looking for a good place to escape to when the winter weather is cold here, that's a great place to go. Fit Scientific is our professional services and engineering company based here out of the East Coast. GoXtudio is really our product design and development company. And just a little bit about Joe and myself, 50 years combined Army service. We both retired 2014. Spent a lot of time doing Army acquisition, doing Army engineering, some time teaching cadets product design, mechanical engineering design, and the importance of going through a really good requirements development process to get to a good product. And had a lot of good projects that we did with DARPA, with ARL, with AFRL, and NATIC. And we decided that we could ultimately take that out into a company and do that. So that was kind of the start of GoXtudio. Watch this video here. 11 feet was done a couple of years ago in the NFL Combine. Mr. Rogers here jumped this amazing distance, and at the time everybody was floored. And it was really crazy because, like, how the heck can somebody do that? Okay, it was 11 feet. Of course, what's probably even more amazing is, for those who may follow things like that, is back in February, Byron Jones out of University of Connecticut did over 12 feet. Okay, so why in just the space of a couple of years could somebody go from 11 feet to 12 feet? What was it that allowed that individual to do that? And one of the things we already know is exactly what's happening. I mean, from a biomechanical standpoint, we have the understanding to recognize that there are really only a few key variables, 4 that we can measure, and we can pretty much predict exactly what the distance of that individual would be. Ground reaction force, the velocity of the center of gravity, the angle at which that person is starting their trajectory, their leap, and also the angle at which the center of gravity is located from where the feet are doing the push-off. We know those 4 things. We can predict with very good accuracy how far that person's going to go. Well, wouldn't it be nice if, whether it's a long jump, or whether it's preparing for a 12-mile ruck march, or whether it's getting ready to go out on patrol, or whether it's trying to sprint out of an ambush, if we understood enough about what was going on to be able to optimize our performance so that each time for each task we're operating at our best efficiency. So that has started a whole series of projects that we've been doing at GoXtudio, working with the Army to go after that. And up front, we have to figure out what are all the things that are talking about here, because there's really 2 different things that come into play here. First of all, there's this idea that the human and human performance in particular is kind of a multi-scale problem. It goes all the way down to the cellular level, and it goes all the way up to the social and human dynamic level. You know, why is it that the same person with the same training regimen on one day is going to have a great run or go that full distance, and on the next day they might kind of sputter out? They might have what we used to refer to as tiny heart syndrome, and they just can't quite seem to get there. What's going on? Same person, same training regimen, same things going on. Well, that's where part of that multidimensional piece comes into play too, right? There's more than just the physical. We've got this social issue. We've got this cognitive piece. We know that if that person is not just operating alone, but if their squad leader, their teammates are with them, encouraging them, getting them go on, they'll go on even past what they did the day before, or with better performance, because there's this other aspect of what's happening. One of the big benefits we've got right now is there's a lot of great work that's been done, and when my buddy Joe was at DARPA, he was a DARPA robotics PM as we were both wrapping up our career. He was a big proponent of OpenSim, which is a program that was run out of Stanford and is being done. He actually provided some of the funding to kind of get them up and off the ground. And what you're looking at here is actually a study that was done by some colleagues of ours to look at the impact of putting bracing into place for individuals when they're doing airborne drops. And you can see what's going on when this piece of equipment is strapped onto the simulated soldier here before it's actually strapped on. So this is really kind of neat, right? Because in CAD, for years we've been able to test equipment and look at what's going on with machines kind of without the person involved. But with systems like this, and it's still very early, I will tell you OpenSim still has a long way to go before it's ready to test everything, but we're getting to that point now where we can strap a rucksack on or we can put a brace on and we can see what's happening with muscles, with bones. At what point do we hit that place where the ankle's going to have an inversion that's going to create some sort of a sprain? So we're leveraging systems like that as well. What is wearable tech? You don't have to read all of this. If you are somebody who's involved with a company, industry, or somehow with acquisition, you might get really excited because you realize, wow, there's a lot that goes into wearable technology, and I'm sure I can carve a piece out for me. If you're a soldier who's looking at somebody like me talking about this, you're going, oh, God, look at all that stuff they're going to strap on me. Are you kidding me? But it's important to understand all the pieces that go into wearable technologies, because folks here, folks out in this audience are strapping all of this stuff on. And it's very important to recognize that when we start to put this onto a soldier, an airman, or a sailor, we can do some great things to help them improve their performance. Only if we're smart and recognize the entire universe of everything that is strapped onto that person and what the impact's going to be. Because if we just keep putting it on there, and if we haven't taken into account that there is a whole system, then the one little thing that we're trying to optimize in terms of performance may not actually work very well for us. Performance is something that we've decided to go after, and after I talk about this slide, I'll start talking a little bit about some of our specific products. This is a graph that shows just some older vehicles and what their fuel efficiency was at various speeds. And it's interesting to note, right, because we know that for most of us, engines are tuned on our cars to kind of have peak efficiency out on the highway, right? And the engines can't do much about that. Now, we can be smart when we're driving in town. We can not keep a foot on the gas and a foot on the brake, and we can try to accelerate slowly. But we all know that our cars just don't perform as well in city driving versus out of city driving. But if we know this about people, if we know what those efficiency curves look like, and that's part of what we're actually working on a project with the Army to help them build out, what do these efficiency curves look like for people? We can, one, help people, help soldiers shoot for those peaks, but we can also help them figure out, because people can make adjustments, how do I adjust those performance curves depending on what the activity is? So that it's one thing when I'm sprinting, it's one thing when I'm going a short distance, it's one thing when I'm going a long distance, and I need to be refreshed when I get onto the objective. Because we can do that. We've got the gray matter up here to do that. We've got the bodies that are robust enough to do that. Robot skin is really kind of a whole idea behind a line of apparel and equipment that is ultimately what we're going after. Right now, anybody in here wearing a Fitbit? Anybody? No? Okay. You got to watch, yeah, or a smartwatch. There you go. Okay, there you go, or a smartwatch. You know, it's interesting. Okay, there we go. We got another one. So it's interesting. There are lots of folks kind of operating in the measure space right now. One of the things that's interesting about something like Fitbit is that we recognize, let me go back here, we recognize that the majority of people will take a Fitbit off, I shouldn't say majority, 30 to 50% will remove a Fitbit within 6 months of putting it on and wearing it. Well, why is that? Well, it's primarily one of two things that has happened. One, they've worn it for some amount of time and they say, I just don't get it. I'm not sure what to do with this information, and it's not doing anything for me, so they take it off. On the other end, they'll say, I got it. I modified my behavior, I did the things I needed to do, and now it is no longer telling me anything more that I need to know. Now it's just an extra thing I'm wearing on my wrist. I'm going to take it off. So there's a lot of folks going after that whole measure space. What we're working on with the Army right now on the predict side is being able to actually leverage that information so that the person doesn't just have to think about what it is that I'm being shown, but we can actually provide them feedback in a more useful fashion that says, hey, how well am I operating right now? What does it mean if my heart rate is this? What does it mean if my heart rate variability is something else? What does it mean if my respiration rate is this? And then be able to modify that behavior. Now, why do we talk about modify? Initially, it's us modifying the behavior. But because we also do robotics and we do wearable systems, we know that it's ultimately going to be robotic systems. It's hard to see, but the person who's running on that treadmill in the bottom right is a colleague of ours, and he's wearing a lower body exoskeleton, and his legs are being propelled in part through joint augmentation, and that's based on controlled feedback that says how well he's doing as he runs. And ultimately, that's where we're going to get to with robot scan. Now, I'll be the first to tell you, there's a lot of big companies out there working the full load path to ground systems, and that's not us, not at all. Full load path to ground takes a lot of size, it takes a lot of weight, it takes a lot of power, and it's really expensive. So we've just hit all of the swap-C issues that become a problem when you're trying to get this thing out into the field. Could be great for somebody who can tether to power and operate in a warehouse space or do logistics or things like that, and there can certainly be some uses for it. But if we're talking about soldier, sailor, or airman out in the field or on a ship or on a line operating, what we want is something that can give them a little bit of a boost. Doesn't have to be full load path to ground. Just needs to be a little bit. We'll talk about why that is. One of the projects that, and I guess I should note, on the insole, I'll go back real quick, that to the left there, that insole, that's actually something that we've got in development right now under CRADA with the Navy. They've got a great IP that was developed by somebody out of NSWC Crane. They've licensed it to us, and then the Army said, hey, we want you to work on helping us quantify human performance up at NATIC. So crazy, we got Army and Navy stuff working together, and as an old West Point guy, it's like, are you kidding me? I'm working with both. But anyway, out of the Army came to us and said, we've got this really cool kind of variable non-Newtonian fluid that we want to see what we can do in straps. You know, do you want to help work with us to maybe go after some products, some commercialization of some things, and to see if we can make straps better? So STF stands for shear thickening fluid. As somebody who was in the Army for 25 years, I can tell you I'm sure I never wore my helmet as tightly strapped as I needed it to. I was always having to correct my soldiers not to look like John Wayne. And as a father of 3, I always worried about my kids not putting their bike helmet straps on tight enough. Everybody who wears a helmet doesn't like the fact that once you put these rigid straps on, it's kind of tight and uncomfortable. So what this particular system does, and again, it's about human interfacing with the technology, right? We want to fit the system to the person, not the other way around. So we just simply modified it so that when you pull on it a little bit, or if you're opening up your jaw, the strap gives, and it's much more comfortable. And when you let go, it conforms right back to where it needs to, so you can set it. But if you have a shock event, it locks up just like a seatbelt. Okay, so it's real simple, real straightforward. Happy to pass that around and take a look at that if you want. I've got it over here at the table if you want to take a look at it later. Again, some Army technology that they came to us and said, hey, help us figure out a good way to put this into a product and maybe get it out there. And finally, another part of what we've been working on, this is actually a US MedCom project. I wanted to show you the actual whole advanced modular mannequin, which we just delivered to our prime, but we are in a phase 1 competition right now for or 3 other teams are competing, and they said, you can't show them the final, you can show them pieces and parts. So I'm showing pieces and parts. The key thing here is that the technology we're building is really a patient simulator. Advanced modular mannequin. We had all the mechanical portions of it, and the idea was, again, take it back to kind of the human-machine interface. Government and everybody was tired of having to purchase a brand new simulator every time you wanted new appendages to train folks. And when you look at these simulators, if anybody's seen them, most of them now are between $65,000 and about $100,000 for the full system. Well, it turns out for these advanced ones, the most expensive stuff is what's in here. So if you could come up with a standard chassis that has all your computing systems, has your fluid pumps, has all of that, and then have standard connectors so that third-party vendors could give you gunshot arms, they could give you amputation arms, they could do other things, then this could be a system that you buy the chassis, you buy the torso, and then you just have much less expensive arms and legs, and maybe it lasts a little bit longer. That's the purpose of this project here. A key part of that was making sure that very little training required in order to get somebody up to snuff, in order to put all of the attachments on it and get it connected. How do we link to Army needs? If we can fully quantify the effects of human augmentation, then we can be smart about what it is that we're doing to humans. A project that some colleagues of ours were working on is called the 4-minute mile, trying to take soldiers who could run, say, a 6-minute mile and get them up to a 4-minute mile pace for short bursts. That's great. But I've also talked with doctors who are like, do we want to get everybody who is only capable of running a 6-minute mile to run a 4-minute mile? What's the impact of somebody doing that over time? Kind of like the TV show Limitless, if anybody's seen that, where there's this brain access augmentation pill, and what happens over time? It tears the body down if you're starting to push it beyond certain capabilities. So we need to understand that a little bit better. That's what we're doing. It's also important to understand that this idea of optimization is something that really needs to be looked at kind of from cradle to grave. Who are the folks we're bringing in? How are we setting them up appropriately for training? If we're going through basic training, do we train everybody the same way? We want men and women to have access to the same MOSs. We know that we can probably do it. We know that women are out there who can do many of the same things that our Rangers can do. But what do we need to do to train them up for that? Or men who might struggle with some of the training to do the same things as their Ranger buddies, but we could probably train them up to do that too. But what that takes is tailored understanding of each individual and tailored programs to get them up to speed. And if we do it right through a career, then we will have fewer folks like myself who have fused portions of spines and reconstructed shoulders and all of the other stuff that happens with a lot of wear and tear over the course of 25 years in a career. So we want to avoid that. And finally, if we can do that at the individual level, now we have the opportunity to look at it at the squad level. Because if I can provide the information that's coming back from an individual, how well they're operating, what's their power, what's their efficiency, that's kind of interesting if I know that, right? I mean, think about that. If the squad leader has access to what's going on and you're on an extended patrol, and you can look at everybody and say, gosh, you know, I've got about 35% efficiency across the board here, except for Smith. Smith's running at about 25%. What's going on? Or what if during Ranger training you could monitor that and realize that somebody's getting ready to pass out from heat exhaustion before they pass out from heat exhaustion? Now we can start optimizing at the squad level. Just a couple of key takeaways. The problem is nonlinear, and I kind of started alluding to that at the beginning. If you've ever worn a heavy backpack or a rucksack, you'll know. It's not the first 10 pounds that's heavy, it's the last 10 pounds that's heavy. That last 10 pounds feels way heavier than that first one that you loaded. So what does that look like? It's not the first mile that you run that's the hard mile. It might be the last, or depending on the distance, it might be the one right before you hit the middle, where cognitively you think, I'm not quite at the halfway point yet. We can start figuring that out. Wearable tech program funding is very likely to increase. I was talking with the folks at G8, and robotic systems are gaining more and more interest, enough so that folks like Stu Hatfield, who's kind of really shepherding a lot of that work, may at some point get some separate funding for that. There's a big push now that we are kind of rolling out of the last decade's worth of slap hazard, acquisition programs into the field to try to get an arm around what's going on with robotic systems. Wearable tech is part of that. It's actually grouped under applique systems. So if you ever see applique systems, that includes slap on and patch on to trucks, to cars, or other things, but it also includes slap on and patch on to soldiers. Tech must fit to the soldier, not the other way around. That's a key part of what we're working on. How can we make the soldier's performance better by adding something, not how can we put something on the soldier, make a buck for it, and get the soldier some improved performance. We really do want to focus on that. SWaP-C is critical, and the really cool thing about this particular area is we are on the verge of just a great set of opportunities and advances as the technologies themselves have decreased and as our understanding of humans and human performance has increased. That's all I have. Any questions? Sir? SWaP-C, size, weight, and power. C is cost. So it's really important whenever you're looking at any acquisition to take that into account, but especially when you're looking at materiel that's going to go on to a soldier, that you take that into account. And especially when we talk about a soldier, so many of the things that we put onto a soldier require batteries. And I can tell you that, pounds and pounds of batteries then get loaded into rucksacks and have to be carried along when you go out on patrol in order to make everything work. So. Sir?
Sorry about that. You mentioned a lot about wearable robotics and so forth, exoskeletons.
Yes.
What's your thoughts on how long it will take to mature the technology of a full exoskeleton?
Yeah, so it depends on what you mean by mature. I will tell you that what we really see right now is the next 5 years through about 2019 is real heavy emphasis on kind of R&D, on educating consumers in general, not just military, but getting consumers in general, the public, used to the idea of putting this stuff on. We just completed a very large kind of global market research effort on wearable technology, and what we're seeing is that the early stuff is actually passive, and there are even already crews. Europe is actually way ahead of us on this right now. That's one of the reasons why we started up the trade association, is because the US is actually behind. Asia and Europe are charging full steam ahead. So if you go to airports now in Asia, there are already passive lower body exoskeleton devices that assist airport workers in the airport as they do their jobs. There's a company in France that has already deployed some upper body exoskeleton systems to assist pavement and construction workers. So here in the US, people are playing with it and doing it. The good news is the majority of the companies working on it here in the US are small, so it's very innovative. The larges are starting to catch that. It's the old line industrial companies that are attacking it in the West, and they're throwing, in Asia, they're throwing lots of resources behind it. And it's a mix of folks in Europe. But we really see 2020 as being kind of a seminal year for really changing it, from a Department of Defense standpoint and from a global consumer standpoint, because you're going to start seeing more of it. The challenge that getting back to exoskeletons in particular, they're here, and it depends on what you want the technology to do as to how much it can do. People have to decide, do you want the full load path to ground or not? The stuff that is not full load path to ground is easy. It's out there. I've worn the systems. I've run around in them, run upstairs, run downstairs, and there's lots of different ways to do it. And that'll be ready in 5 years. An Ironman-like suit is going to take longer, because right now that's a lot of weight and it takes a lot of power, and without a tether, you'll have challenge with it. That's why I've suggested, and I've talked with folks, that the best place to start that is a place where tethered power is easy. And then you can prove out the efficacy of it, and then you can figure out over time how to get it off there. Yeah. Any other questions? Sure. Yeah.
I am Collier Slade. With the emphasis on physical optimization through augmentation, are you concerned about a disconnect with the mental and the cognitive optimization?
Yes. So that's actually a big issue. The particular project that we're working on right now with the Army in terms of quantifying human performance and figuring out what are all the parameters that get involved has a team that includes a number of folks out of industry and in the government, but we've also pulled in a lot of folks out of academia. One of them is a Dr. Paul Davenport out of University of Florida, and he specifically focuses on sports psychology and the cognitive side of the technologies and how you can look at what's going on with the wearer and how it's affecting their performance. So absolutely, it's extremely important, because when we start even talking about trying to optimize performance at the team level, how do you present that information to the person? Is it something that they have to read? Is it something that is spoken to them? Or is it something as simple as, hey, let's look at these first-person shooter games, and these guys and gals have grown up with these things. Maybe there's some good, easy barcode ways to do that. Same thing with even giving that feedback to the wearer. If I want to adjust how somebody is getting ready to launch on a jump or move or row, is the feedback better in an auditory standpoint, a visual standpoint, or maybe it's haptics? Some people respond differently than others, but I think that's part of what we have to understand is how can we better tailor to the individuals.
Okay,
I
great.
think we're all finished?
Yes, thank
all
you
right.
so much.
Thank you all very much.
And just so all these presentations, once they get the approval from Bruce, these presentations will be available on our Google Hangout site. So I know a lot of people are taking notes, but